Good morning everyone. This is Minidhi. I am here to continue our class from next topic, that is resistance in parallel. Before going through it, let us solve one question from NCERT book on resistance in series. Here is the question. The question is, draw the diagram of a circuit consisting of a battery of 3 cells of 2 volt each, a 5 ohm resistor, an 8 ohm resistor and 12 ohm resistor, and a plug key all connected in series. Now let us draw a figure. The three resistances is given, which is connected in series, that is of 5 ohm, 8 ohm and 12 ohm. 3 cell battery is connected, which is of 2 volt each. Therefore the total voltage around the circuit is 6 volt. Total potential difference, that will be equal to 2 plus 2 plus 2 equal to 6 volt. Now since the resistances is connected in series, then the total resistance that will be equal to 5 ohm plus 8 ohm plus 12 ohm, that will be equal to 25 ohm. Since we know that the same current is flowing through the resistances when it is connected in series, therefore let us consider I current is flow through the series. Now total resistance is 25 ohm and the total potential difference is 6 volt. Therefore current I equal to V upon R by Ohm's law. Implies that I equal to 6 upon 25. That will be equal to 0.24 ampere. Since the current in the circuit is 0.24 ampere, therefore total current is 0.24 ampere. Now moving towards our next question, that is, redraw the above circuit putting an ammeter to measure the current through the resistor and a voltmeter to measure the potential difference across the 12 ohm resistor. What would be the reading in the ammeter and voltmeter? As we know, the voltmeter is connected in parallel and the ammeter is connected in series. When we redraw the figure, then we find ammeter is connected in series, there is a plug, and the voltmeter that is connected in parallel. Since we have to find the potential difference across 12 ohm resistor, therefore we connect the voltmeter in parallel to 12 ohm resistor. Now here in figure B, the reading of ammeter is 0.24 ampere. Since the current in the circuit is same, therefore I equal to 0.24 ampere, resistance that will be equal to 12 ohm. Now we have to calculate V, that is potential difference across 12 ohm. Therefore V equal to I into R by Ohm's law. Implies that V equal to I. Here the current is 0.24 and the resistance is 12 ohm. That will be equal to 2.88 volt. Hence the potential difference across 12 ohm resistor is 2.88 volt and the reading of voltmeter is also 2.88 volt. Now moving towards our next topic, that is resistances in parallel. जब भी हम रेजिस्टेंसेस को पैरेलल में जोड़ते हैं तो रेसिप्रोकल ऑफ रिजल्टेंट रेजिस्टेंस होगा वो बराबर होगा सम ऑफ रेसिप्रोकल ऑफ इंडिविजुअल रेजिस्टेंसेस. This will be explained with the help of figure. Here the resistance R1 and resistance R2 are connected in parallel. When we calculate the resulting resistance across the resistance R1 and R2, that is 1 upon R equal to 1 upon R1 plus 1 upon R2. Let us consider that resistance R1 is of 6 ohm and R2 is of 12 ohm. Therefore, the total resistance is calculated as 1 upon 6 upon 1 upon 12. That will be equal to 1 upon 12, 2 plus 1. That will be equal to 3 upon 12 upon 4, implies that R equal to 4 ohm. We have to derive this formula where the reciprocal of combined resistances is equal to the sum of the reciprocal of all the individual resistances. For this, we have to keep 2 points in mind. The first, when a number of resistances connected in parallel, the potential difference across each resistance is same. Let us understand these 2 points with the help of a figure. Here is a resistance R1 and resistance R2 is given, which is connected in parallel. Therefore, the potential, when we connect this with the battery of V volt, then the potential difference across each resistance R1 and R2 is same, that is V and V. But the current in the circuit across the resistance R1 and R2 is different. This is our second point. Here current is I, but when it flows through the resistance R1 and R2, it will be I1 and it will be I2 across resistance R2, and the total current is I. Then we find the total current I equal to I1 plus I2. This is equation first. We know that I equal to V upon R by Ohm's law. This is our equation second. When we put this value in equation first, then we get V upon R equal to V upon I1 plus V upon I2. This is our equation third. Implies that when we take V as common, therefore 1 upon R equal to 1 upon R1 plus 1 upon R2. Implies that 1 upon R equal to 1 upon R1 plus 1 upon R2. Here is the derivation. In similar manner, we find the resultant resistance of 2, 3, 4 and so on resistance combined in parallel. Now let us solve some numerical on its basis. The question is, the first is calculate the equivalent resistance when two resistances of 3 ohm and 6 ohm are connected in parallel. This is of 3 ohm and this is of 6 ohm. Now the resultant resistance 1 upon R equal to 1 upon 3 upon 1 upon 6. That will be equal to 3 upon 6 equal to 1 upon 2, implies that R equal to 2 ohm. Now our next question is, in the circuit diagram given alongside total resistance of the circuit, we have to find total current flowing in the circuit and the potential difference across resistance R1. Now in the figure, we see that it is a combination of series and parallel combination of resistances. For this, the resistance R1, R2, R3 is given, in which R1, R2 and R3 is connected in parallel. Then we have to find the resultant resistance across this. Therefore, let us consider that the total resistance across R2 and R3 is R. Then 1 upon R equal to 1 upon R2 plus 1 upon R3. Therefore 1 upon R, that will be equal to 1 upon 8 plus 1 upon 12. When we take the LCM of 8 and 12, we get 24. 3 plus 2, that will be equal to 5 upon 24. Now total resistance R equal to 24 upon 5, 3.8 ohms. Now the circuit that can be redrawn as, this is R1 and this is now R. The resistance is 4.8 ohm and it is of 7.2 ohm, which is connected by a battery of 6 volt. Now total resistance, we have to calculate total resistance, that will be equal to 7.2 plus 4.8. Since by series combination, we have studied it earlier by series combination, then we get, that is 12 ohm. This is the answer of our first question, that is the total resistance of the circuit. The total resistance of the circuit is, our answer is 12 ohms. Now moving towards our second question, that is total current flowing in the circuit. Total resistance is 12 ohm and the total voltage, that is potential difference equal to 6 volt. Therefore V equal to R into I, implies that I equal to V upon R, that will be equal to 6 upon 12, 0.5 ampere. The total current flowing in the circuit is 0.5 ampere. This is our second answer. Now the third one is the potential difference across resistance R1. In the series combination circuit, the current flowing through it is same, then I equal to 0.5 ampere, and the resistance, we have to calculate the resistance, the potential difference across resistance R1. Therefore R1 is 7.2 ohms. V equal to R1 into I, that will be equal to 7.2 into 0.5, which is equal to 3.6 volt. And this is the answer of our third question, that is the potential difference across R1 is 3.6 volt. This is the end of our class. If you like my video, don't forget to subscribe the channel. Thank you.